right, so let's see if we can finish this section up today. If not, we'll go from there. But anyway, here is the standard equation of a circle. And the center is at HK and the radius is R. Notice it is a plus sign joining the two. And also notice the coefficients in front, each of those factors is 1. So that has the number 1 in front of both of them. And it also has a plus sign. That also helps you determine it's a circle. I don't know, you could put HK, AB, a lot of different definitions, but that is a standard equation of a circle. What other equation of a circle is, or what other form? Do you remember? Another equation of the circle? No. Okay, it's known as a general equation, in which everything is squared out. So you have x squared minus 2xh plus h squared plus y squared minus 2yk plus k squared equals r squared. Now the reason that's important is when you're given the general equation of a circle, usually it's given to you as x squared minus 2xh plus y squared minus 2yk plus h squared plus k squared minus r squared equals 0. Usually you're given that to you, and this whole thing is usually a number. Okay? It's usually one single number. Now, if you're given the equation in a standard form, or the general equation, you have to complete the square to find the center and the radius. Complete the square. And not do it once, but do it twice. Okay? The only reason I show this at the same time is because I want you to see why you're completing the square, because not a lot of people know that h squared plus k squared minus r squared, you can't figure out what that number is going to be. So you ship it off to the side, and off you go. Well, that's the general equation of a circle and the standard equation of a circle together. All right? So you'll know instantly that you have to complete the square. I love completing the square twice on a problem. I mean, you're going to definitely get that question at least 10 to 12 times this year. I think it's a great question, along with finding the equation of a line. Those are all great questions. Probably some applications here. Sketch the graph of a circle or semicircle. How do you know if it's a circle or semicircle? Well, let's just worry about the circle. This is a circle, right? X minus h squared and y minus k squared. A lot of people don't get it. But when you're given a form, you should actually work at that form to understand what's happening. So if I rewrite it using the definition, I know the center is at 4, negative 2 with a radius of 2. Okay? Very easily, straightforward. It doesn't get much easier than that. All you have to do is make a sketch of it. Like I said, it's not a semicircle because it doesn't have any radicals in it. Putting these on the graphing calculator is a bit difficult. We don't even really mess with that for right now. So yeah, you just make a sketch. 1, 2, 3, 4, down 2. And then a radius of 2 means you're going to go 2 other directions. 1, 2, 1, 2, 1, 2. There's your 4 dots. So if I ask you for a sketch, that's what I would expect. Okay? The center and the radius. What word describes this circle in the x-axis right now? It's one word. Starts with a T, ends with a T. Has an A-N-G-E-N in the middle. Tangent. Why do I say that? Oh, it's supposed to be tangent. Sorry. Bad sketch. Because a lot of great questions say, find the equation of a circle with the center at 4, negative 2, and tangent to the x-axis. It's another way of wording a radius of 2. Okay? So this circle is actually tangent to the x-axis if I, drew it to scale. Okay? So it's actually tangent. Tangent means they have one point in common. Okay? All right. So far, so good? I like that question. I like the word tangent. It's very trig and very calculus. All right, I'm not sure if that's a word, but I like it. Sketch the graph of the circle or semicircle. What the heck is that? What numbers can you put in for y? Can you put anything you want in there? 10 bajillion? 25 minus 10 bajillion squared would be a negative number. And since we're working on the real graphing axis, can't have negatives in the square root. So y has to be what? Positive or? Right. I mean, this whole expression right here, 25 minus y squared. You had this thought. You just had this section in your book on your test because I graded the test. 25 minus y squared has to be greater than or equal to 0. Correct? It's the square root. So that means that, 25 has to be greater than or equal to y squared. So y has to be between what two numbers? Yeah, 5 and negative 5. You can take the square root and you get 5 and negative 5. So y has to go between those two numbers, and it can't equal 5. What numbers are x going to go to and from? What's the biggest x can be? What's the smallest x can be? Okay, if I put let's see, 0 in for y, the square root of 25 is 5, and you have a negative, right? So x can be negative 5 when y is 0. When y equals 0, x can be negative 5. Okay. See how I'm kind of doing it backwards? That's because y is now the independent variable, and x is the dependent. I'm putting numbers in for y to generate x. Times if y equals 5, what does x equal? 0. And then, is y ever going to equal a positive 5? I mean, negative 5? Sorry. So what would x equal then? 0. So when you make a sketch of this, I'm still going to put the x along the horizontal and the y in the vertical. If y is 5, then x is 0. If y is negative 5, x is 0. And if x is negative 5, y is 0. There's no memorizing on some of these problems. It's just thinking about it. That's what I like about these problems, the thinking. If you can think your way through, you're fine. I think that works, doesn't it? It's a semicircle. X is negative. X is negative in the second and the third quadrants. X is negative in both of those. Here, y is negative and positive. I think that works. Questions on that? It's just going through thinking about it. And writing down enough steps until you see what's going on. That's not a question. That's just an idea of thinking about it. All right, 34. Oh! Here it is, tangent to the x-axis. Find the equation of a circle that satisfies the stated conditions. I love that question. I love the word tangent thrown in there. So take a few minutes and come up with that. See if you can come up with an equation. I need to take these off. I'm sure everybody got the first answer. X minus 4 squared plus y minus negative 1 squared equals, and the radius would be what? 1, yeah. Squared, not negative 1, 1. That's the distance from the center to the x-axis. Radius is 1. So that's pretty nifty. It doesn't say what the equation has to be in. Which one is this? Is this the standard equation of the circle? What's actually the general form of the equation? I'm just going to run through it real quick, okay? Just so you get an idea that if you come up with this answer on a test or a quiz, and it's asking for the general equation, well, you'll know how they got there. X squared minus, plus, I think you need to practice, because you need to be able to do this kind of quickly. You know you want to double the product, minus 8x plus 16 plus y squared plus 2y plus 1 minus 1 equals 0. Okay, you need to be able to jump back and forth quickly. I think they put the squared first, the more I think about it. I'll go x squared plus y squared minus 8x. I think powers trump variables. So I think 2 trumps the x. It's been a while. Plus 2y. 16, 17 minus 1 is 16. All right, so you can have your answer one of two ways. And now you know how to go back and forth between the two. Okay? I think it goes order first and then in the order of the alphabet second. Okay? Yep.
I think it goes the other way, from the long equation to the standard form.
Oh, you group the x's? That's a great question. Perfect timing for it also. So I take x squared minus 8x. You remember I always do that whenever I complete the square? I put that little blank in because I'm forgetful about things like that. Y squared plus 2y. I group those second. And then I always take the constant to the other side. You can keep it, and play around with it, but I just get rid of it right away. So negative 16. And since I have 2 blanks on the left, I'm going to add 2 blanks on the right. Okay? And then you always cut it in half, negative 4, and you square it to get 16. Then you cut it in half to get 1, square it to get 1. Then whenever you add to the left, you have to add to the right, 16 and 1. And I don't really write these down, but I know that this is going to be my factor. X minus 4 squared plus y plus 1 squared equals 1. Okay? Hopefully that's what we started with. Yeah, it is. Nice. Okay? So I just complete the square twice. That's a great question. Everybody in the room is going to have to demonstrate that skill on a quiz or on a test. I think we're ready to move on. Find the center. Oh, look at that! The next one was it. Look at Kyle. He's very excited, aren't you? I'll tell you what. I'll give you, how long do you need? Like 30 seconds? 45 seconds? A great coach told me one time that you got to keep them moving. You got to keep them moving. You can't let them sit still. I don't know, I'll give you, whoa, I just lost it, whatever it was. There. Okay, I'm going to lock that. Well, now shoot, the effect of the timer is over now. 30 seconds. While I close the door. Nice. Let me get caught up. No, that's time for you. That's why I started. Let's see. Oh, plus 0y plus blank equals negative 18. All right. No, you don't have to put the 0y in there, but I did just to show something later. Let's see. Half of that, square it. Half of this, square it. And add the 25 and the 0. All right. So far, so good? All right, so we have x minus 5 squared plus y minus 0 squared equals 7. Yeah, so the center would be 5, 0. And the center, or the radius, would be the square root of 7. Yes, you can. I just did that to show the actual form of the equation. So like 75% of you got it right, right? Show of hands, you got it right. Good. Yep. Yeah, you can. Okay. You can just put y squared, that's fine. All right, good. That makes me feel pretty good. 76. Oh, wait, that's a big jump. From 50 to 76? Wait a minute. Yeah, I don't know. Good luck with that. You can figure it out. All right. Expressed in interval form, the x value such as, oh, I know what's happening. y1 bigger than y2. So you need to write intervals in which the graph in blue, oh, sorry. Where is the graph in blue bigger than the graph in red? For what x values is that true? Well, the graph in blue is bigger when y1 is less than y2. I got it backwards? Let me see. Oh, yeah. So when's the graph in red bigger than the graph in blue? Well, it looks like from here that way, red's bigger than blue because it's above it. Oh, from this little stretch, from here to here, looks like red's bigger than blue. And from here out, looks like red's bigger than blue. Notice I didn't color any of those dots in. I left them all open circles because at the dot, they're the same, aren't they? And the question says strictly less than. So the neat thing about this question is you go from a one-dimensional number line to a two-dimensional number line. They just put another number line vertically. I don't know if you ever thought of it like that or not. But if it said answer in terms of y, you'd be doing it the other way. That's the neat thing about calculus is they ask you to do things the other way as well. So you'd go from like, what is this, -2 or negative infinity to -2. This one's from -1 to 1. Is that right? Wait a minute. I'm doing x's. It's -8. Sorry. -8. -1 to 1. And from 8 to infinity. And how do I join more than one interval? The union symbol. That's not bad, is it? Okay? Fantastic. It was easy. Yep. What's our graph of? Which one? Oh, the equation itself? Well, I'd say the one in blue is, I don't know, let's see, 1, 1 and -1. -1 is 1, 1 is 1, -8 is -2, and 8 is 2. It's decreasing. Is it a no? The cube root, maybe? Yeah, if I put in 8, I get -2, so it's reduced by a cube. But over there, it's not positive. It's also negative. Something squared has to be going on also. Oh, maybe the negative absolute value. That could work. That could work, couldn't it? Yeah, that could work. For the red, I don't know about well, maybe the blue is just I don't know. We can figure it out later. We're going to do some regressions. Oh! Do you see the next question? I love the next question. That's where you have to get out the calculator. But you can figure those out, can't you? Or do you want to do it together? You want to do it together? But what about our 10 for 10? What do you mean, nah? Don't you want points?
No.
All right, let's do this one together. Where is my calculator? Here it is. There we go. All right, graph the equation of the absolute value of x plus the absolute value of y equals 5. View. Y equals. You remember what absolute value is? Math, number, absolute value of x, plus. Now, some people might have a different looking screen because of the newer models, but absolute value of, how do you do absolute value of y? Oh, they're telling you how to do it. I see. If you want to graph the whole thing, you have to do it in steps. I know. They're saying that you have to have two equations because the absolute value of y equals 5 minus the absolute value of x, correct? What's the two possibilities for y? Y could be what? Positive or negative. So we already know if y is positive, we write y equals 5 minus the absolute value of x. Well, what if y was negative? You would take the opposite of that, wouldn't you? That's why this equation says, in the second one, take the opposite of y1. And I think we did the variables already, didn't we? Vars. Okay, good. We've already done the vars. So, I think we're ready now. So, y equals the absolute, let's clear this off. Clear. All right, 5 minus the absolute value of x. 5 minus the absolute value, math, of x. And then y2 is the opposite. Go to vars, which is next to program. Hit that button. Go to yvars, function, and then y1. There. And it says the viewing rectangle of negative 5 to 5 by negative. What does that mean? Do you remember?
Oh, I mean, y max.
Yeah, x minimum, x minimum, x max, y minimum, y max. And you find those under the window of your calculator. So I go back to the calculator. Window is at the top. Second button over from the left for me. Negative 5 to 5. Scale of 1. Negative 5 to 5. Scale of 1. Graph. Nice. You gotta be kidding me. What is that thing? Yeah? Oh, is your plot on? If you have an error, check your plot. Yeah, you got to turn all those off. There. Now finish. All right. So how many, based on that graph, how many x and y intercepts are there? 2. 0, 5. That's a kind of a neat picture. Negative 5, 0. 5, 0. 0, negative 5. Oh, so it'd be 4 altogether, right? Use a graph to determine where this would be less than. Oh, I want to ask you this question. Yeah, sure. What would it be less than? What region? What are you talking about? See, we're not on a number line. You can't go left and right, in between. This is like two-dimensional inequality. It would be. Always pick a test point. It's either going to be inside the square or outside the square. Does 0, 0 work? Yes, it does. So the answer to the question would be everything inside the square satisfies the equation in part B. I like those questions. We're going to have to do more of them. Yep. Wouldn't the line be what? Well, I know. I just asked them about the region because I figured everybody in the room knew it had to be dotted. Nice. That's the same as an open circle, right? How do you make? Oh, I can do that. Go to your calculator. Go to y equals. Go back and hit dotted. Hit enter, 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 enter. Bubbles are cool. Have you ever seen a bubble graph? I love those. There's dots. They go down. You scroll over. Oh, but it's really not the same. If I go to dots. Am I hitting the wrong button? No, there we go. Shade above, shade below. Nice. Nah, you know it's not different. You know it's different though. Okay? All right. So nice job. What we got? Like 10 minutes left? 5. So what page are we on? 52. And we're doing like 27 through what? 116? All right, page 116, 27 through what? 77 odd? Yeah, that'll be good. Perfect.